Hello everyone. Title of this video is section 7.5 part 1 on proportions and similar figures with rational equations. So in this video I'm going to be going over a version of the Knewton Alta homework for this section 7.5 part 1. Please understand that the questions I see in this version are not, they may or may not be the same questions that you see when you work on the assignment on your own. Alright, but the objectives are the same. The types of questions you see will be similar. How you work on them will be similar. Right? So hopefully watching me go through this helps you in some way when you're working on the assignment on your own. Alright, and I would request also that whenever a new question pops up on the screen in this video, pause the video and try to work on the question yourself first. See if you can figure it out. And then watch me do it. Alright, because if you're just watching me do it without practicing yourself, you're probably not going to learn much of anything. Alright, so here's the assignment page. Again, you will not see the words preview of. You'll just see the title of the homework assignment, the mastery bar telling you how far along you've gotten. You have the objectives here. There are 2 objectives in this assignment. And then every question should have at the bottom a feedback button to send feedback to Knewton if you want. You will not see the instructor cheat button. That's just for instructors only. But you should be seeing a more instruction button, which I highly recommend taking advantage of. If you're working on an assignment and you're struggling with a question or an objective, click on the more instruction button and some extra reading material or videos related to that objective will appear, and hopefully that extra instruction helps you when dealing with a certain objective. Okay, so this first question is on the objective solve application problems, right, word problems or whatever, involving similar figures. Alright, so I'll talk about what it means for 2 figures to be similar. So when they say here, triangles DEF and NPQ are similar, that means that the ratios of corresponding sides are always the same. And I'll write this out when I take this to paper. Right. So we're told here, if triangles DEF and NPQ are similar, what is the length of side, with little q, right? Now side Q here in the diagram is the length of side PN or NP, right? The segment NP. And enter your final answer as a simplified fraction, right, or just a fraction. All right, so I'm going to draw this up and talk a little bit about what it means for 2 figures to be similar. All right, so I did my best to draw some triangles here. We have triangle DEF and triangle NPQ. And they tell us that triangle, right, this is the symbol for triangle, hopefully it's obvious why. They say that triangle DEF is similar to, and that's what this little tilde symbol means. I'll write that down for you. Right, if you ever see me use this symbol here or this in other texts, this means is similar to this other triangle NPQ. Now pay attention to how the figures are named, because the letters should correspond to one another in a particular way. I'll talk about that, what that means here. So in similar figures, when we say two figures are similar, one, all the corresponding angles are congruent or have equal measure. All corresponding angles are congruent. Right, meaning the same, they have the same measure. Right. So you got to pay attention again to how they're named to say what angles are corresponding. Alright, so in this picture here, they named the triangles. They said triangle DEF is similar to triangle NPQ. So angle, right, this is the symbol for angle. So angle D would be congruent. Alright, this is the symbol for congruent. Angle D, the first letter in the name of this triangle, would be congruent to angle N, the first letter in the name of this triangle. Alright, so if I was making little tick marks up here, remember this, make this mark here, the one tick mark, one arc mark, means those angles are congruent. And then the second letters in the names correspond. Angle E in the first triangle would be the same measure, be congruent to angle P in the second triangle, right, with the second letters. So angle E, and I'll put two arc marks on that, would be congruent to angle P, right? And then finally the third letters correspond, right, F and Q. So angle F would be congruent to angle Q. So the measure of this angle, and I'll put three arc marks, would be the same as the measure of this angle, right, angle Q in that triangle. Alright, so that's one thing about similar figures. In similar figures, all the corresponding angle measures are the same. All the corresponding angles are congruent. Alright, and here's the important part, the one we're going to use. Secondly, the ratios of corresponding sides are the same, are equivalent. Ratios of corresponding side lengths are equivalent. All right, and this is the big one. This is the important one here. the fact about similar figures that we're going to use in these questions. So again, pay attention to how they're named, because that matters. So the side from D to E, right, the side between the first two vertices, the first two letters here, the ratio of that side to its corresponding side. Now ratio means, division, right? Fraction, divide. So if I take the first two letters DE divided by the corresponding letters in the other one, NP, so the length of DE divided by the length of NP should be the same value as EF to PQ. The side from E to F to the side from P to Q. Now, pay attention, make sure that if you're setting up, now this is called a proportion, what I've just set up. A proportion is just an equation where two ratios or two fractions are set equal to each other. Alright, this is called a proportion. And just make sure that the numerators are coming from the same triangle. Alright, anyway, the way I like to set it up anyway. the numerators are from the same triangle and the denominators are from the same triangle. All right. So the ratio of length DE to NP should be the same as the ratio of EF to PQ, and that'll also be equal to the ratio of D to F, right, the third side, to NQ. Right, all three of these should be the same value. Right, and again, notice the way I'm setting it up is all the numerators are coming from the same triangle, all the denominators are coming from the same triangle. Just be consistent. And again, pay attention to how the figures are named, because it'll tell you what sides are corresponding to what sides. Alright. But this is key. Alright, this is what we're going to use to set up our equations. Now, in this question, they want us to find little q. Let me separate this here. Now, little q is the length of NP. Right, and that corresponds to length DE. Right, DE are the first two letters of the first triangle. NP are the first two letters of the second triangle. So NP corresponds to DE. So I'm going to set up this proportion. I'll take DE from the first triangle, that length, divided by NP, which is going to be this little q. And I want to set that equal to another ratio of corresponding sides, right? Because again, the ratios of corresponding sides should be equal in similar figures. I want to set that to another ratio of corresponding sides so that q is the only unknown. Right? Because watch what happens when I do this. How about if I take DE to NP equals EF to PQ? Right? They should be equal because they are ratios of corresponding sides. Look at what this equation looks like, though. DE has a length of 5 halves over NP is Q equals, and then EF has a length of little d over, and then PQ has a length of 11 halves. Right? There are two unknowns. I don't want that. There are two variables here, two unknowns. I want to set up two variables. Oops, right? Oops. I want to set up these proportions so that there's only one variable, and then I can solve for it. Find a value. So instead of that ratio, instead of this proportion, instead of taking DE to NP and setting it equal to EF to PQ, I'm going to do the following. I'm going to take DE to NP, right, the ratio of those corresponding sides, because again the NP has the Q I want, and instead of doing EF to PQ, I'm going to do DF to NQ. And once again, set it up so that the numerators are from the same triangle and the denominators are from the same triangle. All right, so let's look at what that equation looks like. All right, so DE again has a length of 5 halves. Now I'll make the middle bar longer, right? Because we're going to have a complex fraction here, right? You see, I have a fraction within a fraction. And then NP has the length of Q. Equals, and then the DF to NQ, DF has a length of 7, and NQ has a length of 9, and this is much better, right? See, this is good, right? Only one variable, so I should be able to find a value for that variable, that Q. Okay, well, first, I like to do the following. All right. So first, I like to simplify any complex fractions, if there are any. any fractions within fractions, which the left side is. Alright, this left side is a complex fraction. You see you got the main division bar here between DE and MP. And then above that you have a fraction again, right? Fractions within fractions. Now, you may recall a pretty simple way to do that is to multiply everything above the main division bar and everything below the main division bar by the LCD of these two fractions. Now there's only one denominator here, and that's 2. So I'm going to multiply the numerator by 2 and the denominator by 2. And that'll cancel that 2 in the numerator. So I have 5 in the numerator over, and then 2 times q in the denominator equals, and then the right side is not a complex fraction, right? It's just a simple fraction, single fraction, 7/9. Okay. And now I'm solving, and then solve the rational equation, right, which you should know how to do. Right, this is a rational equation, an equation with fractions, right? And you should know how to do this from section 7.4, part 1. Right? So I'm hoping it's obvious here that the LCD for every, all the denominators in this equation would be, 2 times q times 9 would be 18q. Right. And then I multiply both sides by 18q. Multiply both sides by the LCD. And the whole reason for doing that, right, is so all the denominators get canceled, all the denominators go away. All right, on the left side, the q's would cancel, and then 2 goes into 18 9 times, so you'd be left with 9 times 5, or 45. You'd have 45 on the left side. All right. And on the right side, 9 would go into 18 twice, so I'd be left with 2. Alright, 9 goes into 18 twice, and then I'd have 7 times 2q, which would be 14q. And now I have a much simpler equation to solve. Right? Divide by 14, q equals 45/14. And this is the length of that missing side, the side that they asked us for. All right, that would be the length of NP here. All right, this would have to be 45/14. And that's as simple as that fraction gets. 45 is 5 times 9, or 5 times 3 times 3. 14 is 2 times 7. Right? There are no common factors, so that's what they want me to enter. Right? Enter it as a fraction. All the way back here, q equals 45/14, 45/14. Alright, now after every question, whether you get it correct or incorrect, there should be an answer explanation. Alright. Please read through it, whether you got it right or wrong. If you got it correct, read through it to make sure you got it right for the right reasons and that you didn't just get lucky. Or, maybe they do it in a different way than you did, and a way you didn't think about that maybe you like better and you'll put to use in future questions. Now, if you got it wrong, definitely read through the answer explanations, right? Because hopefully you'll figure out why you got it wrong, where you went wrong, and learn from your mistakes for future questions. Alright, so continuing on, next question. Now this question, solve problems involving proportions. Now remember, proportions, I've mentioned the word proportion already. It's where you have a ratio equal to a ratio, a fraction equal to a fraction. Alright, that is a proportion. And as I did with the first question, when you set up a proportion, just be sure you're consistent. Make sure the numerators are coming from the same place, and the denominators also. With these questions, though, you just have to make sure that the units are consistent. Right? You're going to see units involved. All right, so I'll pull up. I'll keep the work up here. All right, and you can see my paper. And once I'm done writing out the stuff, I'll make the paper bigger. Right. So read through this, right? It says Sneha or Sneha. I don't know how to pronounce that. I apologize. Drinks a 27-ounce energy drink. All right, so notice ounces, right? Ounces is a unit here. Containing 137 calories. Right? So calories is another unit. Per 9 ounces. All right, so when they say the energy drink contains 137 calories per 9 ounces, per means division, basically. You've seen miles per hour, dollars per gallon, right, in real life. That's division. So if there are 137 calories per 9 ounces, that means every 9 ounces of the drink contains 137 calories. Or I'll set this up. We have this ratio of 137 calories per every 9 ounces. And I'll put OZ for ounces. So this is the ratio of calories to ounces in this energy drink. And this should be equivalent to the size of the energy drink, this same kind of energy drink that Sneha is drinking. And when I set up this proportion, again, this is called a proportion that I'm setting up, a ratio equal to a ratio. Make certain that the numerator units and denominator units are consistent. All right, numerator units and denominator units should be consistent. What I mean by that is you see how this ratio on the left side that I've written, the numerator has the units of calories. So I would like the numerator units on the other side to also be calories. Right. And on the left side, the denominator units was ounces. So then I would like the denominator units on this side to also be ounces. Right. And then reading back through it, it says that Sneha drank a 27-ounce energy drink. So that's going to go in the denominator with the ounces. Right? Again, the way now you could flip them over if you want, but just be careful. Just pay attention. Make sure your numerator units are the same and the denominator units are the same. The question is, how many calories did she drink? So I'm going to call this, X calories. All right, this is the unknown. All right, the question was, how many calories did she drink? And over here is the ratio of calories to ounces for what she drank. Over here is the ratio of calories to ounces for just the energy drink in general. All right. I'm hoping this makes sense. I'm going to be doing this with every question, right? Setting up this ratio equal ratio stuff, right? So I'll make this bigger now. So here's our proportion. Now, as long as your units are consistent, right? Calories in the numerator, ounces in the denominator here, you can stop writing them, right? So just 137 over 9 on the left side equals X over 27 on the right, and then we solve this. Right? Now, just like any other rational equation, I'm going to find the LCD. Now, the least common denominator here would be 27. Right? 9 goes into 27 evenly. 27 obviously does. So I'm multiplying both sides by 27. And that should do it, because you'll see the right side has X alone. Right? The 27s would cancel. And then on the left side, 9 goes into 27 3 times. So I'm really just left with 3 times 137, which would be, let's see, that's 390 plus 21. All right, 390 plus 21 be 411 equals x. All right. But remember this represented, though, the number of calories she drank. All right, so I could answer she drank 411 calories of energy drink. I'll just write 411 calories, right? If you want to write a complete sentence. But all they're asking us to do is fill that in, right? Fill in a blank back here in the assignment page. All right, so just how many calories did Sneha drink? 411. All right. I hope that, again, you'll see probably 3 other questions where I do this, but setting up a proportion, just make sure, again, your units are consistent. Numerator units are the same, denominator units are the same when you're setting up those ratios. Once again, please, read through the answer explanations. So they put C for calories instead of X. No big deal. Right? Okay, next question. All right, so this is again, and we're back to that objective. Solve problems involving similar figures. All right, so again, I'll keep this up. And hopefully you can see it here, and we got triangle ABC is similar to triangle XYZ. Once again, pay attention to how they're named. A corresponds to X, B to Y, C to Z. The lengths of 2 sides of each triangle are given in the figure. Find the length of side little x and enter a fraction or a mixed number. Alright, so here's the diagram. Now little x, right, they're asking us to find little x. And little x in this picture is the length of YZ in the smaller triangle on the right. Right, that's the length of YZ. Right. So I know this might be confusing. There's a little x and a big X. Right. I'm going to try to make them distinguishable. Alright, so YZ, side YZ, that corresponds to, well, YZ are the second and third letter of the name of that triangle. So that's going to correspond to BC. Right, this corresponds to length BC. So I'm going to set up this proportion here. So I'm going to have BC to YZ or YZ to BC equals, right, there's a ratio of corresponding sides, equals, and then I'm going to set up another fraction over here so that the numerator is from triangle ABC, the denominator is from triangle XYZ, and I want to set it up so that the only unknown is this X. All right. Well, I can't use AC because AC has length little b. Right? I don't want to use that. I'm already using BC in the first fraction, right, the left fraction. So how about AB, right, length AB. Let's do AB, and then AB would correspond to XY. Alright, so I'm going to put in the numbers here. Now BC has a length of 7. YZ is the length X, little x, that we're looking for. Equals AB, right, and the triangle ABC has length 8 over, and then XY in the smaller triangle has 2 2/3. 2 2/3. Remember, this is 2 plus 2/3 when you see a mixed number. Alright, it's 2 plus 2/3. Let me pull that back up. So really this is 8 over 2 plus 2/3 for real. Alright, because most people, I personally don't like mixed numbers because people often confuse it with multiplication. not 2 and 2/3 like this means 2 plus 2/3. Or you could write 8 over 2 and 2/3. When you add them together, this is 6/3 plus 2/3 is 8/3. Right. So here's the proportion I have. 7 over x on the left equals 8 over 8/3 on the right. And as I did with an earlier question, the right side here, this is a complex fraction. I'm going to make it into a simple fraction by multiplying the numerator and denominator by 3. All right, that'll cancel this little denominator of 3 down here. So now I have 7 over x equals, and then 24 over 8. And this reduces nicely, actually. All right, 3's cancel, and then got 24 in the numerator. 8. See the 8, you'd be left with just 3. 7 over x equals 3. Then I multiply both sides by x, right? The LCD. Right, the LCD is just x. That's the only denominator now. Right, 3 over 1. So the left side would be 7 when I multiply by x. The right side would be 3 times x when I multiply by x, and then dividing by 3. X would be equal to 7/3. There's the length that they're looking for. 7/3 or 2 and 1/3 if you want to enter it as a mixed number. But all I'm entering is, I'm going to enter as a fraction. Right, x equals 7/3. And submit. And again, please read through the answer explanations when you are finished. All right, moving on. Next question is on back to the solving problems involving proportions. Again, you see how this is almost exactly the same, just with different numbers as the earlier question involving ounces and calories drank, and so I'm setting up a very, very similar proportion here. So once again, I'll pull this up. I'll keep the problem up on the screen, and it'll be kind of tiny, but that way you can read it. And I'll set up the proportion and then make the page bigger. So it says here, Mark drinks a 57-ounce energy drink containing 97 calories per 19 ounces. Again, the word per implies there's a ratio, a division there, right? Miles per hour, dollars per gallon, etc. So I have this ratio. There are, for this energy drink in general, there are 97 calories per, divided by per 19 ounces. Again, I'll do OZ for ounces. And this ratio should be the same as the ratio for the energy drink that Mark is drinking. Alright, and again, keeping consistent with the units. The numerator is calories. Now the question is, how many calories did he drink? So this is unknown, so you could call it X or C for calories, like I think they did. So Mark has drunk, X calories, and we're going to solve for X per the 57 ounces that Mark drank. So over on the right side, I have a ratio for the drink that Mark drank, and on the left side, I have the ratio for just that same energy drink in general. And they should be equivalent, right, if he's drinking the same kind of energy drink. Alright, so let me pull this up. There it is. Once again, you can, you don't have to write the units, just again make sure they're consistent. So I have 97 over 19, that ratio on the left equals X over 57 on the right. The LCD is 57. Alright, 57 is actually just 19 times 3. So I'm going to multiply both sides by 57. Alright, multiply both sides by the LCD. That'll cancel these 57s over here. and 19 goes into 57 3 times, so really I'm just left with 3 times 97 on the left. Well, 3 times, that'd be 300 minus 9, 291, right? And then on the right side, you just have x. So there you go. And remember, this represents number of calories that Mark drank, right? So Mark drank, 291 calories worth of this drink. Now you don't have to write a sentence or anything like that first question, right? You just have to fill in a blank. So 291. Great. All right. And please read through the answer explanations. All right, so another question. This time it's not about like drinking an energy drink, but it's still the same setup. We're still going to have a similar setup. We're setting up a proportion, setting two ratios equal to each other, and just making sure that the units are consistent. Alright, so once again, I'll make this a little tinier. We'll pull it up here. I'll read it off and write the ratios as we write the proportion as we go through. Alright, so it says here, for every 6 kilograms, for every is like per. Alright, miles per gallon, that's, so many miles for every gallon. Dollars per miles per hour, so many miles for every hour. Dollars per gallon, it costs so much money for every gallon. Right? So for every 6 kilograms of a child's weight, pediatricians prescribe 17 milligrams of acetaminophen. So there's a ratio right there. They prescribe 17 milligrams for every, right? 17 milligrams for every or per, 6 kilograms of a child's weight. So there's one ratio, and this ratio should be equal to what the doctor prescribes for little Lexi here, right? So it says if Lexi weighs 48 kilograms, how many milligrams, mg, of the acetaminophen, right? That's aspirin, right? Tylenol is acetaminophen, right? Will the pediatrician prescribe? So on the right side, right, again, the numerator I would like to be in milligrams of acetaminophen, right? Because the milligrams was on the numerator of the left side as well. And the denominator will be the kilograms of the child's weight. And over here the ratio, this left ratio is for children in general. The right ratio is for just Lexi, this Lexi person. And Lexi weighs, 48 kilograms. That'll go in the denominator, or kilograms, right? And the question is, how many milligrams of this drug, this acetaminophen, will the doctor prescribe? So again, I'll call that X. Right? I don't know. That's what we're trying to find. So we have, getting rid of the units now, we have this proportion, 17 over 6 equals x over 48. Solving this rational equation. Right? So I'm going to go back and make this a little bigger. Here it is. Now again, I'm hoping you can see the LCD is 48. Right? This isn't always going to happen, but so far with these questions, one denominator goes into the other denominator evenly. Right? 6 goes into 48 8 times. Right? 6 times 8 is 48. So the least common denominator is 48. Multiply both sides by 48. And 48s are gone over here. 6 goes into 48 8 times. And then you're left with 8 times 17 on the left. 8 times 17, that'd be 80 plus 56. It's 136 on the left and x on the right. And there you go. And don't forget what this represented. This represented the, amount of milligrams of acetaminophen that the pediatrician would prescribe to Lexi. So I'm not gonna. You can write that out in a sentence if you want, right? The pediatrician will prescribe 136 milligrams to Lexi, right, of acetaminophen. But back on the page, I'm just filling in a blank with 136. Notice it's milligrams after, right? You don't have to type in milligrams, right? Milligrams is already there. Right, wonderful. And again, please read through answer explanations. All right, next question. Looks like one more problem here, solving problems involving proportions. Now look at this. This one, you are given a proportion. A fraction equal to a fraction, ratio equal to ratio. And has to solve it, right? Solve for u here, right? So I'm going to write this out and we'll go through it. And you solve it the same way you solve any rational equation with fractions. Alright, so I'm hoping you can see that the LCD would be 12, right? Just 3 times 4. That's the least common multiple of 3 and 4. So I'm going to take the whole left side, that one fraction, and multiply it by the LCD, right? Multiply by 12. Same thing on the other side, right? It's just a single fraction, right? U minus 7 over 3. Also multiply this by the LCD, right? Multiply by 12 on both sides. Now that should cancel the denominators, right? 4 goes into 12 3 times. So on the left side, I'd have a factor of 3 left over. Now be careful. Don't write 3 times and then write 3u plus 4, because too often people confuse this and say, oh, just 9u plus 4. This 3 that's left over is multiplied by the entire numerator. 3 times the quantity, 3u plus 4. Equals, and then the right side, 3 goes into 12 4 times. Right? So I have 4 left over times, again, the entire numerator times the quantity, u minus 7. Right? Not just 4 times u, but 4 times all of u minus 7. Now you may have seen cross products before for proportions, means and extremes. These are the means, these are the extremes, whatever. These are just the cross products, right? 3 times the quantity 3u plus 4, 4 times the quantity u minus 7. You can do that for proportions if you wish, but I'm going to stick to multiplying both sides by the LCD, right? Because that's the way you do it for any rational equation, not just proportions. Alright, then we simplify, right? Distributing the 3 over here, distributing the 4 over here. We have 9u plus 12 on the left, 4u minus 28 on the right. I'd subtract 4u to get 5u on the left, subtract 12 to get negative 40 on the right, and then divide by 5. U would be negative 8. And don't forget to check the solution. And I'll do this out loud. I'll do it out loud. Replace u with negative 8. This side would end up being negative 5, right? You'd have negative 24 plus 4, which is negative 20 divided by 4 is negative 5. You'd have negative 5 on the left, and then negative 15 divided by 3 is negative 5 on the right. You have negative 5 equals negative 5. Negative 8 is the valid solution for this equation. Alright, so yeah, no different than any other rational equation, right? Multiplying, find the LCD, multiply both sides by the LCD, and that'll get rid of the denominators, and then you solve the resulting equation, and of course check your solution, right? My solution was u equals negative 8. Great. Alright, and that's it for the proportion. I mean, we'll set up other proportions when we have similar figures, right? You've seen with similar figures, you set up a proportion and solve it. But that's it for the the objective specifically on proportions. All right, now we should have a couple more questions with the similar figures objective. So once again, You got these two figures here. This time, this is pretty much the same as the first question, only instead of finding little q, we're asked to find little d. All right. So again, I'll pull this up so it's on the, you can see it here. It's tinier, I apologize, but yeah, pull some new paper. Now little d, right, that's side length EF. Right, that's side length EF, which corresponds to, in the other triangle EF corresponds to side length PQ. Right, because look, EF, that's the second and third letter of DEF, and PQ is the second and third letter of MPQ. Alright, so I'm going to do EF over PQ. Alright, that ratio of corresponding sides, should be the same as the ratio of any other corresponding sides. And once again, I want to set it up so that little d is the only variable, right? So I can't use NP, right? I can't use NP. NP has little q. I don't want two variables. I just want one variable. So again, I'm going to do DF, the ratio of DF to NQ. And once again, pay attention. Make sure that the numerators are coming from the same triangle and the denominators are coming from the same triangle. Alright, so I'll write this out, and now I'll make this a little bigger. Alright. So EF, that was little d. Oh, sorry, I'll just say it. Right, side length PQ is 11 halves. Right, so what I have on the left side, pardon me, wow. So what I have on this left side is a complex fraction, which I can easily simplify. I'm just going to multiply the top and bottom here by 2. Then on the right side, DF, that's 7 over, and then NQ had a length of 9 units. Right, so 7/9 on the right side. Alright, so left side, pretty simple to, first I'm going to simplify this complex fraction. I'm going to multiply the top and bottom by 2. That'll get rid of the 2 down here, right, this little denominator of 2. Alright, so I have this proportion. We have 2d over 11 on the left, right? 2d over 11 on the left equals 7/9 on the right. And I'm asking, I'm just solving, right? Solving this just like any other equation with fractions, right? The LCD would be 99, right? 9 times 11. I'm going to multiply both sides by 99, both these fractions by 99, and that should cancel all the denominators. On the left side, right, 11 goes into 99 9 times, so I'm left with 9 times 2d, which is 18d. Right side, 9 goes into 99 11 times, so I'm left with 7 times 11, or 77. And then I would divide by 18 to get d alone, right? D equals 77/18. And these don't have any common factors. That's 7 times 11. This is 2 times 3 times 3. There are no common factors, so that's as simple as that gets. And please, go back and check it in the original equation if you want, but that should work out. Now I know you probably could see something faster. Obviously, if you see anything faster than mine, that's totally valid though. As long as you're doing valid, legitimate mathematical moves, go ahead and do that. I'm just doing it in a very methodical way where, simplify complex fractions, multiply both sides by the LCD, and then, get the variable alone. And it works every single time, so that's why I'm doing it for you this way. Alright, so back here, right, D equals 77/18. Enter a fraction or a whole number. We got a fraction here. All right. Okay, and again, they set up the proportion, do all that. Wonderful. Okay. Read the answer explanations. All right, now I should have just one more question like this. All right, so this is triangle ABC and XYZ that were in the second question I saw from this objective. And we're asked to find, instead of little x, we're asked to find this time little b. All right, now little b is side length AC. All right, so let me pull this up again. New piece of paper. All right, so little b. All right, little b is side AC in that big triangle, triangle ABC. And side length AC corresponds to side length XZ in triangle XYZ. Right? Look at the way they're named. AC are the first and third letter. So are X and Z in the other one. Right? You got to pay attention to how they're named. So AC corresponds to XZ, which is a length of 3. So I'm going to set up this ratio, AC over XZ, and this ratio, since these figures are similar, this ratio of corresponding sides should be equal to any other ratio of corresponding sides in these two triangles. And once again, pay attention, make sure my numerators are coming from triangle ABC and the denominators are coming from triangle XYZ. And I would like to set up this proportion so that little b is the only variable. So I'm not going to use side YZ that has little x as a side length, right? So I've already used XZ, I'm not going to use YZ, so I'm going to use XY from triangle XYZ. So I'm going to put that in the denominator over here, right? Same triangle. They're coming from the same triangle. And XY corresponds to AB. Right? So I have AC to XZ equals AB to XY. Right? And let me write all this stuff in. Now AC has little b as a length. XZ has 3 as a length, right? So the left side is a simple fraction, just b over 3. The right side, AB has a length of 8, right? So numerator is 8. And the denominator XY has a length of 2 2/3. All right, so we have, remember this is 2 plus 2/3, and I would actually prefer to write this as 8 over, 8/3, which when you simplify it, if you multiply the top and bottom by 3, you'd have 24 over 8, which is just 3. Right? We saw all this earlier. Right? If I multiply the top and bottom of this by 3, we'd have 24 over 8, and 24 over 8 is just 3. So here's what I have. Very, very simple setup here. We have b over 3, and I'll go to make the paper bigger now. We have b over 3 equals, 8 divided by 2 2/3 is 3. And wow, I would just simply multiply both sides by 3 and get b equals 9. I hope you see that, right? I'm not going to write all that. Right? LCD is 3, multiply both sides by 3. You got b on the left, 3 times 3 is 9 on the right. Check that, right? All right. And check it, is 9 divided by 3 the same as 8 divided by 2 2/3? Yes, it is. They're both equal to 3. Right, so this works. So back here, b equals 9. Right, the length of that one side is 9 units long. Wonderful. And that should be it. All right, so again, remember that when you have similar figures, pay attention to how they're named to know what sides correspond to what sides. And then you're setting up ratios. In your proportions, you have ratio equals ratio. When you set up your ratios, just make sure you're consistent, right? The numerators coming from the same. The numerators are coming from the same triangle, and the denominators are coming from the same triangle. That'll make it easy for you. And then solve the equation just like you would solve any other rational equation. Great. And that should be it for this version of this assignment. As I said at the top of the video, right, the questions I saw in this version may or may not be exactly the same as the questions you see when you work on the assignment on your own. All right, but the objectives are the same, the types of questions are similar, how you would go about doing them is the same. Right? So I'm hoping that watching me go through this here helps you when you're working on the assignment on your own. And thank you very much for watching.